All right, thanks for joining me today. We are going to talk about chapter 0.5, which is rational expressions. Our objective here is to perform operations and simplify rational expressions while understanding domain restrictions. Now, our main focus here will be understanding domain restrictions. We're going to talk quite a bit about that and do it on almost every problem. So similar to rational numbers, rational expressions are in the form of a fraction. So rational means fraction. Okay. So I have some expression, such as 2x plus 3, or I could also have x minus 1, in the form of a fraction. So if I put a bar over it, that's a rational expression right there. Domain is defined as a set of numbers which define the expression. And what I mean by define the expression is when I put a value in here for x and I get out a real number, that defines it. Okay, we're only looking at real solutions of this. Okay, so we use set builder notation. Okay, and that's in the form, we got a set of numbers, and we always say that x is an element of your reals. This is a little e right there. And this is kind of like your paragraph symbol, but instead of a p, it's an r. So this and this could be whatever variable we have in there. This tells us that our variable to start off with is any real number, such that, and this is where we get rid of some values, because the real number system is huge. So we might put in here, for example, that x cannot equal 1, or that x has to be bigger than equal to 0, or x is bigger than 1 but less than 10. Okay, these are the kind of things we'll put in over here, depending on my expression here. Okay, so find the domain. Now, when we look for domain, we have to think about what values of x, when I put into my expression, will make it imaginary or not, undefined or unreal. Now, the only things we've really talked about are with a fraction. With a fraction, I cannot have 0 on the bottom. Okay, and we may have talked about that with a radical, or you probably talked about in algebra 2. With a radical, I cannot have a negative underneath here. Okay, so these are my two kind of red flags when I'm looking for domain. So if we're looking at the simple polynomial, 2x squared minus 5x plus 3. Think about it. Is there any number in here that when I work it out gives me number 1 imaginary and number 2 gives me undefined? Well, no, there's nothing in here. I could put positive, negative, fractions. I could put any number I want in here. So in this case, we'll say x is an element of the reals. I could choose any real number. I could put pi in here. And when I put pi in there, I still get out a real number. Okay, so here we've got 2x plus 1 divided by x minus 4. Now we've got a fraction here, so our red flag over here of 0 on the bottom, I can't have that, should be going off. So this number down here, x minus 4, cannot be 0. Well, what makes that 0? Well, if I add 4, x cannot be 4. That's my restriction. So we'll say, first off, x is all real numbers such that x cannot equal 4. There's your domain. Okay. Does it matter what's on the top? No. It's just like this polynomial. This can be anything. The problem is in the denominator. Okay. All right, this one, 3x plus 1 over x. Again, the denominator cannot equal 0. Well, that's pretty easy because there's nothing to solve for. So we'll say x is an element of the real number system such that x cannot equal 0. I can pick any other number but 0. Why can't I pick 0? Because 0 down here will make it undefined. You cannot divide by 0. Okay, again, the top doesn't matter. This cannot equal 0. So if I take x squared plus 1 not equal to 0 and solve it, we'll subtract 1. Of x squared cannot equal minus 1. Take the square root of that and the square root of that. So x cannot equal plus minus the square root of minus 1. Well, I can't have a negative under here. First off, this square root of negative 1, hopefully you remember, is I. That's an imaginary number. So think about it. Are there any real numbers that I need to get rid of? No. The only numbers I need to get rid of are plus minus I, which are imaginary. So in this case, x can be any real number. It just can't be imaginary numbers. Okay, but we're only worried about the real number system right now. Okay, next slide. Determine the excluded values in the expression. So excluded values and domain are very, very similar. Okay, they're basically the same thing. These over here are my excluded or included values. In this case, like down here, we said x cannot equal 4, x cannot equal, those are excluded. Excluded means I cannot use those values. Okay. Well, with these fractions here, I'm not worried about the tops. I don't care what's in the top. I care what's in the bottom. So we factor it out first if we can. So you should notice this is a difference of squares, x plus 2, x minus 2. Okay. Well, again, neither one of these can be 0, because if one of these is 0, then I get 0 on the bottom. So we'll say x plus 2 cannot be 0, and x minus 2 cannot be 0. So that means x cannot equal, well, if I subtract 2 over there, that's a minus 2. And if I add 2 over there, that's a plus 2. So x cannot be plus minus 2. Okay, because if I plug a 2 in here, one of these will be 0. Well, 0 times, let's say it's 4, negative 4, is still 0. Or 0 times 4 is still 0. So looking over here, I'll factor out an x, and I get x minus 5. Well, again, neither one of these can be 0. So x cannot equal, and sometimes you'll just be able to look at this and tell it. And that's my goal, is hopefully you'll be able to look at this factored one and tell me what it can't be. So I can't choose 0 there, and I can't choose 5 from there. Why? Because 5 minus 5 is 0, so that's why I can't include it. And 0 for x is just 0. So there's my excluded values. Simplifying rational expressions. We're going to factor the numerator and denominator. These are your steps. I like to teach these in steps here. So factor numerator and denominator. State the domain restrictions. Cancel common factors. Okay, so we want to factor the top and bottom. So I have x squared minus x minus 2. So that's factors of 2 that subtract the 1. So it's x, x, 2 and 1. Signs are different. The bigger one is negative. So minus, plus. So that's gone. Let's zoom in here. Okay. At the bottom, I've got a greatest common factor of 2. So if I factor out a 2, I get x plus 1. Okay. So that's factor numerator and denominator. State domain restrictions. So x cannot equal, well, I don't care about this. I'd say 2 does not equal 0. That's okay. X plus 1 does not equal 0. Well, x cannot equal minus 1. So I'll put minus 1. That's my domain. That is part of your answer. Then cancel out common factors. So plus 1, plus 1. So in the end, I have x minus 2 over 2. Now I cannot cancel these 2's right here. Sorry, we're off the screen. Sorry, we cannot cancel these 2 because of this subtraction here. I would have to have every term divisible by 2 in order to cancel. So again, factor the top and the bottom. Factors of 6 that subtract a 1. It's 3 and 2, x and x. Signs are different. The bigger one is minus. Okay, so that's factored. Factors of 2 that subtract a 1. That's 2 and 1, x, x. So signs are different. The bigger one is positive. Step 2, state the domain restrictions. So x cannot be, well, I don't care about the top. I care about the bottom. So what makes this 0? That would be a plus 1. What makes this portion 0? A minus 2. So there are your domain restrictions. And then step 3 will be cancel common factors. So cancel, cancel. You get x minus 3, x minus 1. So you got, it's kind of like a little two-part question here. All right, last one down here. Okay, so we'll factor this. Hopefully you notice that is a difference of squares. X plus 2, x minus 2. On the bottom here, this is not in the standard form we like. So we'll change it over here. We'll say minus x plus 2. But again, I don't want a negative out here. I think we've talked about this before. My leading coefficient needs to be positive. So I'll factor out a negative. Now, before you cancel, you got to do step 2, and that's state domain restrictions. So x cannot equal. Well, that doesn't have an x, so it doesn't matter. And what makes this 0? That would be a positive 2. Now we get to cancel. So you have x plus 2 over negative 1 is an acceptable answer. Or I can divide both of these by negative 1. Minus x minus 2. I would accept either one. This one over here, the minus x minus 2 is probably the more proper answer. But if you can get this, that lets me know that you understand what's going on and you understand the concept. So multiplying and dividing rational expressions. Here are your steps. Number 1, we're going to factor everything. Number 2, we're going to restrict the domain. We're going to do the operation and update domain. That's important. We got to update it, and then cancel what you can. Okay, so factor everything. So we'll go through here and factor everything we can. Okay, nothing factors here. I can factor out a 4x here. So I get x plus 1. Looks like I can factor a 3 out of here. That's 3x plus 1. Looks like I'll factor out an x. X squared plus 3x plus 2. Now I got to look here again to see if I can factor. Factors of 2 that add to 3. 2 and 1, x, signs are the same, they're both positive. So all that goes away, and I'm left with this. Okay. Then it says restrict domain. So x cannot equal. Let's start right here. That'd be 0, minus 1. That one doesn't matter. And then here, this one might be a little tricky. We're going to subtract the 1 and divide by the 3. Remember, we set this not equal to 0. So subtract the 1, divide by the 3, you get negative 1/3. Okay. Then it says do the operation and update. Well, how do I multiply two fractions? I simply multiply straight across. So now I've got all my factors over one bar. Update domain. Well, did we move anything from top to bottom anywhere? No. So I don't need to update. And then last is cancel what you can. So I've got the 3x plus 1, 3x plus 1, x plus 1, x plus 1, my x and my x. So on the top, it looks like we have x plus 2. And on the bottom, it looks like we have 4 times 3, which is 12. And we're finished. Check out division. Again, factor everything. So x plus 2, x minus 2. If you're not comfortable factoring, we need to get you there. Okay, so come in and get some help on that. Here I've got, let's factor out a 3x. So I get x squared minus 4. Again, this can factor. So we'll say x plus 2, x minus 2. Restrict your domain. So x cannot equal 0 and 0 there. So that's it for now. How do I divide fractions? Okay, well, you can copy the first one down, and you're going to multiply by the reciprocal. So I got to flip this one over. So 5x to the third, 3x, x plus 2, x minus 2. Now notice we switched top and bottom here. So now I need to update my domain. I need to see, do I need to add more numbers? We'll go through again. I've got 0 here, 0 here, -2, and +2 there. So there are my new numbers. And again, this one becomes just like the last one. I multiply straight across. Okay. And I cancel. X plus 2, X plus 2, X minus 2, X minus 2. I have 3 X's in the top and 2 in the bottom. So this one and this one will cancel with 2. Sorry. We'll cancel with 2 of these. So I have 5X over, it looks like there's just 3 left. Okay, so make sure you watch the X's and the numbers when you cancel. Adding and subtracting. Again, we got some specific steps. So I'm going to factor everything. You must have a common denominator, so we will get one here. You want to restrict the domain. Perform the operation. Simplify numerator and factor again, and then cancel. Canceling is at the very, very end. Okay, so perform the operation. So we need to factor everything. Looks like everything in this case is factored out. So we want to have common denominator. Notice my denominators are the same, so we're good there. Restrict the domain. Well, this is really X plus 2, X plus 2. And the only thing X cannot be is -2 on both of them. So I've restricted the domain, and you won't have to update that one if you do it in the right order. Perform operation, so I'm adding. So when I add, I keep the denominator the same, and I combine like terms on the top. So I have X plus 3X, that's 4X. I have 7 plus 1, that's 8. It says simplify and factor the numerator. Well, here I see that I can factor out a 4. So I have X plus 2. I'll get rid of that. And now it says cancel. So I get the X plus 2, X plus 2. So I'm 4, X plus 2. That would be my solution. You have to make sure you follow these steps. If you go out of order, you will probably get it wrong. Okay, so factor everything. Looks like we're all factored out. Must have a common denominator. 2X minus 1, 2X minus 1. So we're good. Restrict the domain. X cannot equal. We'll take this not equal to 0. Okay, add 1, divide by 2. So that's 1/2. Perform the operation. So I've got 2X minus 1. And notice we are subtracting this term. So you have 6X minus 2X, be 4X, and 7 minus 9. That's minus 2. Simplify numerator and factor. So we've simplified here. Let's factor. So I can pull out a 2, get 2X minus 1. And cancel where we can. So that cancels with that one. And I'm simply left with 2. So I got my domain restriction and my answer. If I just have this, I'm not talking about this original problem anymore. It's totally different. Okay, let's try some harder ones here. So perform the operation. 3 minus X over 2X plus 1 plus X, X minus 1. Okay. And that's step 1 is to factor everything, which we are all factored out. Step 2 would be find the common denominator. Easiest way is to multiply by each other. Okay, so this one needs the 2X plus 1 in the top and the bottom. And this one needs the X minus 1. Okay, so my common denominator would be 2X plus 1, X minus 1. restrict the domain. So we're looking here, and we're saying x cannot be, well, this one, subtract 1 divided by 2, minus a half, and then add 1 to the other side, so 1. There's your restriction. Sorry, we're off the page again. And then it says perform operation. Perform operation, simplify, and factor. Well, here I need to, if we have x minus 1, 3 minus x, plus x, 2x plus 1. I've performed the operation. I can't cancel these. I can't say cancel, cancel because of this addition right here. So I need to FOIL all of this out and combine like terms. This is what makes this process long. So we'll go FOIL this. So x times 3 is 3x. X times x minus x squared. Negative 1 times 3, negative 3. Negative 1 times negative x is plus x. Plus 2x times x, 2x squared. X times 1 plus x. So I still have my common denominator here. That's 2x plus 1, x minus 1. Now I combine like terms up here. So I have minus x squared plus x squared, or plus 2x squared, x squared. So we can mark those out. I have 3, 4, 5 x's. Mark those out. And I have my minus 3. And I need to look, can I refactor this? Factors of 3 that subtract a 5. Well, factors of 3 are 1 and 3, and those subtract a 2, so that cannot be factored anymore. And I'm finished. Okay. All right, so here we go again. Factor everything. We look good. Common denominator. So this one is missing the x squared. And this one is missing the x plus 1. So my common denominator here is x squared, x plus 1. We need to restrict our domain. So x cannot equal 0 here and minus 1 from this factor. When I perform the operation, we've got 1 times x plus 1, so that's x plus 1, minus 2 times x squared, so that's 2x squared. So this is not in the right order, so we want to rewrite that. So I've got negative 2x squared plus x plus 1 over x squared, x plus 1. I need to see, can I factor this? Well, I need to pull out a negative first. So negative 2x squared minus x minus 1. So factors of 1 that subtract a 1, the factors of 1 subtract a 0. So this would be our answer. And we might write it a little neater. Minus 2x squared minus x minus 1 over x squared, x plus 1. So that would be my answer along with my domain restriction. Okay. Last one here in this section. So factor everything. It looks like we do have some factoring here. So pull out a 2, get x minus 3. Factor this one. Factors of 6, so subtract a 1. 3 and 2, x signs are different. The bigger one's minus. So there we go. Now notice when I go to find my common denominator, they both have an x minus 3 in it. So I'm just going to multiply by what is missing. So this one over here is missing the x plus 2. So x plus 2. X plus 2. Then this one's missing the 2. So 2, 2. So I'll write my common denominator, which is 2, x plus 2, x minus 3. Restrict our domain. X cannot equal, start here. There's no x there, so that doesn't matter. You got a negative 2 from there and a positive 3 from that one. Again, if I take these and plug them in, I will get 0 on the bottom, and I cannot have that. So we'll perform the operation. So we've got 5x, x plus 2, minus, be careful with that minus sign, 2, 7x minus 2. we need to simplify this top, multiply it all out, combine like terms. So if I distribute and distribute 5x squared plus 10x minus 14x plus 4. So if I combine all my like terms, I get 5x squared minus 4x plus 4 over 2x plus 2, x minus 3. I got to see, can I factor this? Well, there's no greatest common factor, but my leading term is 5. So I take 5 times 4 and get 20. Are there factors of 20 that add to 4? Well, factors of 20 are 1 and 20, 2 and 10, 5 and 4, and none of those add up to 4. So we are finished along with my domain. If you don't know how to factor these, get in here or watch the video on how to factor those. Complex rational expressions. These are fractions within fractions, and these are one of my favorite things to do. But you got to be really organized here. Okay, so we'll start with an easy one. Okay, and start with the smallest fractions in here. Well, how do I add 1/3 plus 4? Well, you change 4 into 4 over 1. You need a common denominator of 3. So 4 over 1 changes to 12 over 3. And then you have 1/3 plus 12/3. That's 13/3. Then 2 over 1, you need a denominator of 3. So we'll take times 3 times 3. That's 6 over 3. 6/3 plus 2/3, 8/3. Now, how do I divide fractions? Well, we can multiply by the reciprocal, or when they're stacked up this way, we do outers over inners. And it's just what it sounds like. You take your outside two numbers, 13 times 3, over your inside two numbers, 3 over 8. And I didn't multiply them out because hopefully you notice here that I can just cancel out my 3's and I get 13 over 8. Now don't give me any mixed number here. We don't want that. Just leave this as an improper fraction and we'll be all right. Plus, we're going to deal with letters in here, so this won't even be an option. All right, let's step it up just a little bit here. Okay, so I'd want to factor everything if I could, but I don't see anything I can factor. So start here in the top. So 2 over x plus 1. Well, this is 1 over 1, and my denominator's got to be an x. So I'll put an x here and an x there. So I have 2 over x plus x over x. Well, that simplifies to 2 plus x over my common denominator, which is x. Okay, remember, you add the top, you leave the denominator. Divided by, now this becomes 1 over 1. We need x plus 1. So I put x plus 1, x plus 1. So that goes away. So I have x plus 1 plus 1, which would be x plus 2 over x plus 1, your common denominator. Now again, we have to put on what x cannot equal. Okay, so it doesn't matter in the top, so we start looking at the denominators. Okay, so I can't have 0 from this one. I can't have -2 from this one, and I can't have -1 from this one. So the top one doesn't matter, and then we just look at the ones underneath it. Okay, so that's our domain restriction. Now we'll do outers over our inners. Okay, and I'm going to switch this around because this is not the form that we look in. So I've got x plus 2 instead of 2 plus x. So I'll take my outside, x plus 2, x plus 1 over x plus 2x. And we'll just simply cancel our common terms. So we have x plus 1 over x. And the last one. So we want to factor everything. So let's see, this becomes 2x plus 3. Get rid of that. And this becomes x plus 3, x minus 3. Sorry, I wrote over that. Okay, so this is 3 over 1. I need my common denominator, which is x plus 3, x minus 3. And on the top, we know that I got to multiply all this out in the end anyway. So I'm going to put x squared minus 9. And we need to understand that this x plus 3, x minus 3 is x squared minus 9. So these are the same, so I'm okay. So in the top here, I have 1 from this side plus 3x squared minus 9 over x plus 3, x minus 3. Divided by, now we got to do the bottom. Well, this is 1 over 1, but I need this 2. I need 2x plus 3. Well, again, if I multiply that out for the top, I get 2x plus 6 times your 1. Okay, so I can go ahead and multiply this out. These two are the exact same thing, so I'm okay. So my denominator is 2x plus 3. And then the top, I have 2x plus 6 times 1, so I don't need that, minus x. Now, I need to go through and simplify some of these because I see I can combine like terms. So if I distribute this 3, I get 3x squared minus 27. So I have 3x squared minus, what, 26? 1 minus 27. I'm going to leave this one the same, x plus 3, x minus 3. We've got 2x minus x, so that's x plus 6 over 2x plus 3. All right, so if we look at, we don't care about the top. I'm looking for my excluded values. We look at the next row, that's plus minus 3. The next row is minus 6. And the next row would be minus 3, but I've already got it in there, so I don't need to add it again. Okay. Then we'll do my outside over inside. So take the outside, 3x squared minus 26 times the other outside, 2x plus 3 over x plus 3, x minus 3, x plus 6. So we got cancel, cancel. I cannot factor this one anymore. Okay. So it looks like we're done. So we've got 3x squared minus 26, x minus 3, x plus 6. And that is our, whoop, we're off. So that is our solution along with that one. Okay. Again, so this one was a little bit more difficult. Okay, keep your work nice and organized. If you got problems, make sure you're coming in and getting some help before after school. So we're on suggestive problems, chapter 0.5. So get working on those. If you got questions, come talk to me. This is at THS Mr. Jones signing off.